All right, greetings everyone. Welcome to the third part of the video for section 7.1. And we're going to continue on with looking at solving trigonometric equations. And as you can maybe guess, looking at the meme here is, yes, we're going to bring identities into the fold now. But don't you worry, you won't have to look like this baby here because y'all are going to be superstars at this. Okay, so as we move through this section, you want to keep in mind some identities from the past. So there at the top, we've got our Pythagorean identities. In the middle are negative angle identities, as well as our reciprocal identities, which we've actually already used a little bit in this section. So make sure you either have those committed to memory, or you could pause the video and copy them down. And then before we do an example, I want to give you kind of a general process with which to approach these problems. Now, just like with identity type problems we've done in the past, there's no like specific way I can tell you every time you see this type of problem, do this, but there are some kind of general suggestions I can make as you see here. So the first one is to use your identity somehow, and generally what you want to try to do is put your equation in terms of only a single trigonometric function. Now that's not always possible, but if you can, do that. And then after that, the problem becomes similar to the ones that we were doing at the beginning of this section. So you can use U substitution to change the equation into an algebra problem, solve that algebra problem, meaning find the value for U, and then use your solution from step 3, that value you got from U, along with what you originally had U equal to, and solve your trigonometric equation. Okay, so let's take a look at an example. So here we're asked to solve 2 cosine squared t plus sine t minus 1. And we'll note there at the top in the directions as we're looking for answers between 0 and 2 pi. And notice that in this equation, we have 2 different trig functions, right? We see both cosine and sine. So we want to try to write this in terms of only a single trig function. So how could we do that? Well, first of all, notice that this cosine here is squared, which usually anytime we see a trig function squared, that will hopefully make you think of the Pythagorean identity. So the one that we know is sine squared t plus cosine squared of t equals 1. And notice we can solve that for cosine by subtracting sine squared from both sides. Okay, when we do these cancel, or do this, these cancel, so we end up with cosine squared of t equals 1 minus sine squared of t. And so now we have an equivalence for cosine squared, so we can take that and put it in for cosine squared in our equation. So what this will become then is, and I'm going to draw a little separator here. Okay, so this will become 2 times, instead of cosine squared, we'll put in that 1 minus sine squared t plus sine of t minus 1 equals 0. And now notice our equation is only in terms of sines, which is good. You can distribute the 2 through, so we'll end up with then 2 minus 2 sine squared t plus sine of t minus 1 equals 0. You can combine some like terms here, so we see that we have 2 and a minus 1, so this would become now minus 2 sine squared of t plus sine of t plus 1 equals 0. Here we can do our u substitution, so we could say that this is u equals sine of t. So then the equation becomes negative 2u squared plus u plus 1 equals 0. And then when we solve this type of problem, we usually like our leading coefficient, meaning the coefficient in front of our variable with the highest power there. We usually like that to be positive. And so the way we can make that positive is by multiplying our entire equation here by -1. And so when we do that, we'll end up with now 2u squared minus u minus 1 equals 0. And then I'm going to skip some steps here, but you can check using the AC method, and I would suggest you do this, that this will factor to 2u plus 1 times u minus 1 equals 0. Okay? And then we can solve for the values of u there, which will give us u equals -1/2 and u equals +1. All right, well, there's a lot written here, right? And so we've got that thing down there in the bottom that I just boxed. So we got the values for u, but recall that's not what we're solving for. Right? We're solving for values of t. So we now need to go back up to where we had what u was equal to, which is sine of t, and use that together with our solutions for u to now solve for t. So we have u equals -1/2 and 1, so we can set up two equations, one where sine of t equals -1/2, and one where it equals +1. Okay. If we now solve these, we have to think on a unit circle. Where is sine equal to -1/2? That'll be in the third and fourth quadrants. So I think that'll be 7 pi over 6, 11 pi over 6. And then where is sine equal to +1? Well, there's only one place where that happens. That would be at pi over 2. And now we have our solutions. Okay, and again, these would be solutions to the original equation that did have cosine and sine in it. But remember, we changed this into an equation of just sine. All right, that's it for now. Thank you for watching.